Hi guys, today we're going to talk about thrashing. So thrashing is what happens when a program is spending more time paging than actually executing. So we've talked about paging quite a bit. So this is when a program is actually trying to move pages in and that it needs more than it's actually executing the code that is within the pages. So today I want to talk about the causes of thrashing and then some solutions. So the cause of thrashing is that basically the number of frames are no longer enough for the process that's running. So here if we have I don't know, let's call it P1, and this is the total number of pages that P1 has. So we have 1, 2, 3, 4, 5 pages, and let's say that it was allocated in main memory, let's just say 3 pages. So that's what it was allocated. So it has 3 pages, but now, which was fine. Maybe for a while it was fine. It was executing good. And then at some point, it needed to bring in 2 more pages. And so it's going to try to swap out one of the pages that's already in there for its pages, but then it just is not, enough. It is constantly needs this page, and then it needs this page, and then it needs this page, and so it's going to cause issues. So another cause of this could be that you're doing global allocation, global page replacement, and these pages that were originally allocated to P1 might have gotten stolen by another process. If you don't know what I'm talking about, take a look at frame allocation, that video first. So another thing that may happen is that the OS is constantly looking at the CPU utilization rate. So it's looking at this, so these are your CPUs, and this is the rate they're being utilized, and when it sees a low CPU utilization rate, it's going to increase the multi-programming. So basically that means that it's just going to try to run more programs at once, right? It sees that the CPU utilization rate is low, so it's going to increase the number of programs. And now this is going to eat into the number of frames that are available, and then you might end up with some programs that start thrashing. So one weaker solution is just to always use local instead of global page replacement. So if you don't know what this is, take a look at, again, the frame allocation video. A stronger approach would be to ensure that the process always has enough frames. And so one strategy that you can do that would specifically satisfy this is a working set strategy. And then also we can use what's called page fault frequency to on the fly add and subtract pages, frames from a process. So for the working set model, this model actually looks at the frames that a process is actually using, and it defines groups of frames for that process as localities. So yellow, this is part of the same process. So these are both 2 localities in the same process. So maybe this is, I don't know, global variables, and so all of the things that are messing with global variables in your code have been put into these pages, and now they're grouped together into a locality, and we'll call this locality number 1. And maybe this is another part of your code that's calling some function but not working with global variables. And so we'll call this locality number 2. And if you sit and think about it, this is very common. If you look at your code, you probably yourself could sit there and kind of break things into different localities. And so now it just needs to, so what it tries to do is that when your process is working within a certain locality, it makes sure that you have enough frames to satisfy this particular locality. So make sure that you have this many frames. And then when you switch into, you load a a page from this locality, now it's going to maybe increase, maybe this locality is larger, has more pages grouped in it, and it's going to increase the number of frames that is allocated to the process. So this is kind of a, heuristic way of making sure that your process has what it needs, but it's kind of a wishy-washy way. There's a lot of issues with it. Sometimes the localities are not, clear cut, and so this can still cause thrashing. A more direct approach is paying attention to the page fault frequency. So what you do here is you set 2 thresholds. You set a upper threshold, and you set a lower threshold. So if the page fault rate spikes and goes above a certain threshold, that means that there's a lot of page faults, which means that this process is doing a lot of paging and potentially thrashing. So we give it more frames. Makes sense? And then if it drops below a different threshold, that means that, it's happy, or it's idle, one of the two. And so we can take frames away and we can give it to other processes that are seeing spikes in their page fault frequency. So those are 2 approaches that you can use to get rid of thrashing, or at least mitigate it. So please let me know if you have any questions. As promised, this was a short video. So thank you.